Here we're going to look at multiplying fractions with common factors. Here we have 4/5 times 1/2, and what we're going to do is we're going to use a common factors approach. To use the common factors approach, what we do is we break down any number that is not prime. We can keep the ones where it is that they're at, and I'll show you why in a second. So the numerator of this fraction would be 2 times 2 times 1, and the denominator would be 5 times 2. At this point, in the numerator and denominator, we have some common factors. This times 2 here, and times 2 here. I think you would agree with me that this is really what it is that I have written right now is also equal to this here. 2 times 1 over 5, and 2 times 2 right there. Isn't this right here, 2 halves equal to 1? Isn't anything times 1 itself? That's why we can go ahead and cross this out here, and we'll put a 1 here and a 1 here to be precise, in case it's the only thing left. 2 times 1 is 2, and 5 times 1 is 5. So that's the common factors approach. I do have to still look at my fraction at the end here and my product and make sure it's simplified. With the common factors approach, it already should be simplified because I've done my simplification in this process right here. If we have 3/4 times 6/8, again, we're going to look at any of those where we can rewrite them as a product of their primes. So 3 is already prime. 4 is not prime. What is the prime factorization of 4? Right, 2 times 2. So we have 3 over 2 times 2 times, and then 6 is just 2 times 3, and 8 is 2 times 2, which would be 4, times 2 again, which would be 8. Now we look for some common factors that are in the numerator and denominators. You see a 2 here. We can go ahead and cancel out one of the 2's here. We'll rewrite them as a 1 there. And so it looks like that's all we have. All the other 2's are in the denominator. There are no 2's in the numerator to cancel them out with. So in the numerator, we're ended up with 3 times 1 times 3, which is 9, and 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 9/16. 9/16 is in simplest form. Now, the way to check this, our multiplication approach was 3 times 6 and 4 times 8. 3 times 6 was 18, 4 times 8 was 48. 4 times 8 is 32. I was looking at it and I was trying to simplify and it wouldn't simplify correctly. Divided by 2 in the numerator denominator is 9/16, which does match up. Is this way simpler? Is this way simpler? Well, they're both valid approaches and valid strategies to approach multiplying fractions. Again, continuing with our common factors approach, I have 4 in the numerator here, and I know that 20 can be rewritten as 4 times 5. And that way I kind of save a step right here. So I have 4 times 5 here. I have 14 in the numerator here still, and I have this 4 here and the 5 here. At that point, I can use my common factors approach when multiplying. 4, 4, 1, 1, 14 times 1 being 14, and 5 times 5 being 25. Where I skipped one of those steps, where I did not write out 2 times 2, I did not write out 2 times 7, and I did not write out 2 times 2 times 5. Let's take a look at this problem here. Oh, I recognize here that in the numerator there's a 7, and 28 can be written as a product of 7 times what? 7 times 4 is correct. And then so I also recognize that 100 here can be written as 10 times 10, so that we can work with this 10 that's in the numerator of the other fraction. Using that common factor approach, the 7 matches up in the numerator is with this 7 here. The 10 here, 1 and 1. In the numerator, I'm left with 1 times 1, which is 1. And that's the importance of putting the 1 rather than just crossing them out. And we have 1 times 4 times 1 times 10, which is just 4 times 10, which is 40ths. And that's my answer. That almost looks simpler than multiplying these two fractions out, where we would get 2,800 here. Or would we get 70 here? I know I could divide by 10 right away. Where it is that I would get 7 over 28, and then I'd have to divide by 7 in the numerator and denominator. 7 over 280, that is. And divide by 7 in the numerator and denominator to get 1 over 40. Here's a problem for you. 3/9 times 18/21. Use that common factors approach, and please hit pause. Alright, I notice right away that the 9 here, 18 is just 9 times 2. So we'll cross out one of those 9s there, and we're just left with the 2 there in the numerator. The 3, oh, this can be rewritten as 3 times 7. So the 3 gets crossed out with that 3 there. There both becomes 1. And then so I have 1 times 2, which equals 2. And I forgot to put a 1 here. But 1 times 7 equals 7. And I'm done. You probably took a few more steps there. Ideally, you did something like this. 3 times 3 times 3. And then you could find those common factors and cross them out. 3 with a 3 here. 3 with a 3 here. Both all becoming 1. We've got 6 here, which I should have rewritten as 2 times 3. That's why there's a 3 here and another 3 here. Leaving us with 2 in the numerator and 7 in the denominator. 2/7. Let's use a common factors approach to go ahead and review with this final problem here. Let's break down 15 into its parts. With prime factorization, that's 3 times 5. 20 breaks down into its parts. It's 2 times 2, which is 4, times what? Also 5. Times 14/25. That's just 2 times 7. And 25 for the 25ths there, which is 5 times 5. And then I look for some common factors in the numerators and denominators. Just as long as they're in the numerators or denominators, it won't matter as to which fraction and which factor they had belonged to. We have the 5 here. You can cancel it out with the 5 here. The 2 right here, we can go ahead and cancel out with one of the 2's right here. And again, we'll write 1 for each of those there. What does the numerator end up being then? Right, 3 times 7, which is 21. The denominator is 2 times 5, which is times 5 again, which is 50ths. And that there is in simplest form. Remember, if this was not in simplest form, you would need to simplify it. Otherwise, you would not be doing all of your work. And so this is the common factor approach for multiplication. This is going to help you a little bit later on as we're working towards division and as we work with larger numbers.